I do remember my first time stepping on a refinery going, wow, this is huge.
The dimensions of it are just mind-blowing.
It has thousands of miles of pipeline.
Up to 10,000 valves and 1 million instruments.
All of those things have sensors embedded in them. These vast data stores create a huge opportunity for digital transformation.
And that can really lead to some significant new solutions.
Digital transformation is really about two things. It's about recognizing that the amount of data we have around our existing business gives us a big opportunity to transform the way in which we operate. And digital transformation is also about finding ways in which we can operate in the world that's coming.
Companies in the energy industry today are going through a massive transition. If these companies can't manage the energy transition, which is really about the world demanding more energy, but more energy from sustainable sources, they're going to have challenges operating both from a social license to operate, but also from just the basic economics of doing business.
And then they want to have a autonomous EV racing track where you can upload your code to an autonomous racing.
Shell has a really rich history in digital technologies and data science in particular. We developed a statistics group in the 1970s. And so when I started work in this space in 2013, I was building on a history that we already had. We saw that things were changing. And in particular, what was changing was the ability to take large data sets, to store them in a cloud-based environment, and to use cloud-based computation to accelerate the development of new software.
In 2015, I was really blessed to be given a chance to lead the digital transformation team. Preferably, we want to do this part.
Alisa was a phenomenal visionary. She understood where the technology was going, and she understood the transformation that that could lead to for the company.
I think I've been working with Dan for about 10 years. Yeah. When he came in, he was this young punk with his hair standing up. Even though today he still looks like a punk. Yeah. What I really treasure about Dan is his passion. His passion in using technology to solve problems.
In 2014, we had a big incident where we were lucky that no people got injured. Our control valve failed.
The plug came loose from the stem and it starts oscillating in the process. And at one point it actually broke the body of the valve.
We had to repair the plant. It cost us 3 weeks of unplanned downtime.
We started thinking about how we could use the data that we have already collected to prevent future failures.
I think it is. Yeah, I see some drift here from the left.
We contacted the Shell data science department. They had much more experience in this.
What was fortuitous about the work with Pernis was that it came at a time where we'd been working in this space for quite some time, in shearwater in the UK. And what we'd been looking at was the opportunity to effectively take all of the telemetry data that we had and to use that to train data-driven machine learning models to detect anomalies that humans otherwise wouldn't detect. And so we very quickly saw the opportunity to leverage this approach in Pernis.
We have years and years of data. We started with 15 valves.
We're looking at things like the temperature of that valve, the flow rate of that valve.
Pressures once every minute or once every second.
And we're using that to forecast, if you will, the normal behavior of that valve, and then understand where the behavior of that valve deviates from normal conditions. And when that happens, significantly enough to generate an alert.
The challenge was how to automate that without a lot of human effort. As I said, 20,000 valves in Pernis, but we have like 100,000 valves in Shell.
How do you scale that to run that globally? We needed a machine learning operations solution. We also needed a solution that would scale on the vast quantities of data that's generated from these assets. We were looking to say, well, do we build this ourselves? And I think what we realized quite quickly is we don't want to be an AI platform company. Our focus is around our understanding of the problems that our industry faces.
We spotted a company that is called C3. They were at the cutting edge of developing predictive maintenance, modeling, a lot of algorithms that we saw was appropriate for us.
Yeah, and I think if you can set them up so that they are part of the onboarding process, then we ramp up over time.
We were approached by Shell some years ago, and we demonstrated that we could identify device failure with very, very high levels of precision. This is being accomplished through the application of an entirely new generation of technology called predictive analytics, or AI.
Shell was interested in what C3 AI was building and whether it would be relevant to Shell operations. The challenges they were running into were really around scaling and deploying their software and their machine learning algorithms to the entire footprint of Shell. While the mechanics of the valve were simple, the context of the valve required that each valve had to be treated as its own independent piece of equipment, which meant that you really needed at least one independent machine learning model per valve.
Shell has an unusually gifted team of data scientists. They are professionals. They understand the industry cold. The C3 AI platform enables the Shell data scientists using the tools they've always used before to immediately put these applications to work at full enterprise Shell scale, which is as large an enterprise as there is in the world.
What C3 demonstrated was that their platform was capable of managing 2 million of these models. That was what excited us because it gave us confidence that they understood the problem that we have and that their platform was scalable enough to be able to deal with it as we put these models into production.
The types of these successes tend to be somewhat under the radar because they are all avoided failures, right? So nothing happened, and that's a good thing.
We have repaired 83 valves basically that we would not have found without the analytics. And we have millions of savings on unplanned downtime.
We've now managed to deploy multiple applications into production at scale in really critical areas. We've developed together mechanisms to monitor over 8,000 pieces of equipment every day.
We've been able to expand the scope from just valves. There's literally hundreds of use cases.
We also now collect quite a lot of data, and we collect data using robotics.
They can monitor the position of hand valves. They can detect leaks, gas leaks, but also liquid leaks. They are really helping the operators doing their daily routines.
We then look at how we can turn this data into patterns.
A lot of the opportunities are in optimization.
Optimization is important. We again look at the data. We can see where is best place to put the warehouse and how's the best way to get it out to our offshore location.
There will be hydrocarbons for certain industries. So the question is, how do you produce it in a way that is responsible? How do you produce it in a way that gets to net zero emissions? How do you do it in a way that helps support the planet?
We've also developed technology to optimize performance of things like liquefied natural gas trains. A recent algorithm we deployed to one of these trains in Nigeria resulted in the equivalent of taking about 28,000 vehicles off the road. It's a great example of how AI is starting to have a big impact.
Shell does a lot to try to understand our customers, and that's where AI comes in as well. And they can use multiple sources of data to actually give a much, much more holistic picture of what our customer needs.
Can we actually start to integrate end-to-end architecture? Yesterday we signed off. When you look at the energy system, everybody has a piece of the puzzle. The original equipment manufacturer has a piece of the puzzle. Baker Hughes stepped in with their deep understanding of how equipment operates. The operator also has a piece of the puzzle because they understand how that equipment operates in context. Of course, when you talk about aggregating large volumes of data, you need to do that in a cloud-based environment. Microsoft stepped in there to help us to accelerate the speed of development of our solutions collectively.
We collaborate with C3, Baker Hughes, as well as Microsoft to really look at how we can accelerate our AI journey.
Shell is a long-standing customer of Baker Hughes. So naturally, as our relationship, Baker Hughes' relationship with C3 was formed, Shell became a natural party for us to collaborate on some new innovations on the C3 platform.
We have at C3 AI a deep and committed relationship with Baker Hughes. Baker Hughes has been our partner and customer for the last several years in our bid to take our solution and our capabilities to the energy field altogether.
The Open AI Energy Initiative is a really exciting partnership between 4 founding members: Baker Hughes, C3 AI, Shell, and Microsoft. And really what it aims to do is to start to create a set of industry standards and references around how we bring AI technology to the industry.
The whole point of this effort was to take the learnings and innovation that we have been doing so far with Shell and bring the entire industry along.
If we wanted to be really successful transforming the energy industry, we had to work with a broader ecosystem of partners. So what the Open AI Energy Initiative tries to do is it tries to say, let's work together on a common digital infrastructure from which we can all benefit through fair value exchange, with a common set of open data standards underpinning it, which can accelerate the digital transformation of an asset or a site in the energy sector.
This was really driven by the visionaries at Shell that are by far the leaders in applying artificial intelligence to deliver cleaner, safer, more reliable energy with less environmental impact.
Nobody can go at this alone. It's a societal challenge that we're faced with, and with that we need to collaborate. It takes all of us to drive this decarbonization agenda.
I think this is an increasingly important part of how we look at digital, is how we help it enable our greenhouse gas ambitions.
Let's think about what Shell is doing. These guys have set the goal to reinvent themselves as a zero net carbon footprint company by 2050. This is ambitious.
The demand for green electricity is just growing across the globe. We couldn't do this without digital solutions.
If you look at, for example, electric vehicles, we can look at ways in which we charge those vehicles to make sure that we maximize the amount of renewables that are on the grid at any given time. We have the opportunity to optimize the grid behavior using AI and to balance all of those new loads that are coming onto the grid.
If you take the example of the home, where solar panels are generating solar electricity during the day, but we're storing them in a battery and using them when people are home at night, that's a digital solution. So you wouldn't be able to do that without the right software solutions.
Because at the end of the day, energy transition is urgent. We're going to have to transform the energy system faster than we've ever thought possible. And digital is one key lever to do that.
The companies that do not digitally transform themselves with this new generation of technologies will cease to be competitive.
My hope is in 10 years, we have an energy industry that's producing certainly an abundance of clean, safe, efficient energy, and is able to distribute it to parts of the world that frankly don't have access to it today.
I am very optimistic about the future. I believe technology is there to help humans solve many problems. And Shell is here to produce energy, cleaner energy for the people and for the planet.